flow graph question. So the question is given like this: whatever the given question, first you need to check the number of forward paths. So forward path means from input to output. The main thing, you observe the direction. If it is a forward input, it should be the same direction output. It should not be a opposite. Okay, that is the main meaning of the forward path. So first, if you observe here, 1 G1 G2 1, so you can write here G1 G2, because even if you multiply 1 1, you will get the same thing. So write down directly G1 G2, or you can write 1 1 1 G1 G2 1. Later you need to write G1 G2 only. So next, what it is, 1 G3 G4 1. So I will write as it is only 1 G3 G4 1. Okay, so it is nothing but G3 G4. What is the third path? If you observe here 1 G1 G6 G4 1. So it is coming like this, and it is like this, and it is nothing but G1, and it is nothing but G6, and it is nothing but G4. So like that, it is for input to output. It is not to the opposite direction. If you come like this, G1 and G5, it is opposite direction. So G1 G6 G4 1. And one more thing, we cannot take this feedback. Okay, so even if you observe here, it is a opposite direction. So first you add up, that is G1 G6 G4. So it is 1 G1 G6 G4 1. So you will get the same answer. Next, if you take like this, G3 G5 G2 1. So G3 G5 G2 1. So you can write it directly G3 G5 G2. So after finding the number of forward paths and they gain T1 T2 T3 T4 equation, next you need to find out the individual loops. I have written, to reduce the video size, directly I have written L1 L2 L3 L4 L5 L6 loops, but you need to identify the loops by seeing the circuit. Okay, they will not mention anything except the circuit. You need to find out the paths, you need to find out the individual loops, and you need to find out the combination of 2 non-touching loops and combination of 3 non-touching loops also if available. And you need to find out delta is equal to 1 minus all the individual loops plus non-touching loops minus it is 2 non-touching loops minus 3 non-touching loops. It is continued. So delta 1, delta 2, delta 3, delta 4 value. So how we will find out means whether delta 1, that is whether this is touching to the forward path or not. So that is loop 2. So if path 2 is touching for all the loops, then it is considered as a 1. If it is not touching for a particular loop, then you should write a 1 minus that particular loop. Okay, if the path is touching for all the loops, then this delta values will become 1. Okay, so the final equation what we write is transfer function T1 delta 1 T2 delta 2 T3 delta 3 T4 delta 4 and delta value what we have written here. The same thing you need to substitute the loops. So what is the first loop? If you observe here, G2 and minus H1. So G2 bracket you write down, otherwise it becomes a different meaning, G2 minus H1. Okay, many students do the mistakes, they write it in a hurry G2 minus H1. That indicates it is a different meaning. G3 minus H2. So that is the G3 minus H2. So that is the second loop. And what about the third loop? G5 and G6. So that is a third loop, G5 and G6. And what about the fourth loop? If you observe, this cannot become a loop because it is G1 opposite. Okay, G1 G6 H2. So write down G1 G6 minus H2. Okay, so next similarly G6 G4 H1. There, so I have written all the 5 loops. Combination of 2 non-touching loops. So if you observe here, this loop and this loop is not touching to each other. So you should observe that loops are not touching to each other. So here if you observe, L1 and L2 are not touching to each other. If you observe L1 and L3, here also G2 is there, and G2 if you observe here, it is connected for G5 and also G6. We cannot write it. Okay, and for L1 and L4, here G2 is there, where it is connected, G2 is connected here, and it is G1 is also connected. So we cannot write like that. So you observe the things, and from the circuit which are non-touching to each other. So combination of two non-touching loops, that is only the L1 and L2. Okay. So next, combination of three non-touching loops are not there. So no combination of three non-touching loops. You should mention the sentence, no combination of three non-touching loops. And later delta is equal to 1 minus, that is all the individual loops, L1 plus L2 plus L3 plus L4 plus L5. So all the individual loops plus two non-touching loops, that is L1, L2. We don't have the three non-touching loops. If it is available in any other circuits, you need to mention as a minus and three non-touching loops. Remember, here we do the multiplication, here we had, okay. And delta 1, I have already said, if it is a path 1 for forward path, that is first path G1, G2, all the loops will touch. If you observe here, G1, G2 is the main thing which will touch for all the loops, and for the second path also G3, G4, it will touch all the loops. Okay, all the four paths, which are all paths, if all paths are connected to the loops, all the loops, it is interlinked. So we cannot write a delta 1 as a 1 minus some loop which is a non-touching to the particular path. So you observe with the T1, you observe with the T2, you observe with the T3, okay, and you observe with the T4 paths. So if particular first path is touching to the all the loop, then this value is 1. If this path is touching to the all the loops, then this value is 1. If T3 path is touching for all the loop, then this value is 1. T4 is also 1. So once we shall see this, T4 is nothing but what? G3, G5, G2. So you observe in the circuit, G3 is here, G5 is here, and G2 is here. G3, G5, G2. So that means it is coming like this and coming like this. It is, so it is almost all the loops are connected. So you cannot write as a 1 minus the particular loop which is non-touching to this path. Okay, so that's why all the values will become 1. So now already we know the values, just we need to substitute here. Don't leave this like this only. You need to substitute and write it in the final equation, okay, in the exam.